A2 Maths, composite functions. Right, what I'd like to do is just to grab your whiteboards and have a quick go at these, well, relatively simple questions that will get increasingly more difficult. So what would you do if you had to calculate that? Okay, so just have a think. You can do it on your whiteboard, a little piece of paper. See what you got down. Pause until you're ready. And so the answer you should have got is just 7. Why? Because you're taking the number 2 just there and just substituting it in there. So it's 2 times 2 is 4 plus an extra 3 is 7. Really basic stuff. Nothing too difficult. Let's try it with something slightly different. There we go. Minus a half. Let's see what you got. So you took your minus a half in. 2 times minus a half is minus 1 plus 3, 2. Okay, nothing tricky. What about that? Okay. So what did you do to work that out then? Well, the a value, same as these two, you take that a value and you substitute it in where the x is. So really what you should have just got is 2 times a plus an extra 3. Okay, try that one. F of 2x. Okay, so what did you get? Well, exactly the same as all the others. This is what I mean by a composite function. You've got a function inside the bracket and you're taking that function inside the bracket and you're substituting it into another function. So where the x value is, isn't an x value in a sense, it's whatever's here. The function does to this bracket 2 lots of something plus 3. Now the bracket in this case is 2x. So what do you get? 2 lots of 2x plus an extra 3. Which is where that part comes from. Okay, so I want you to have a go at this. What do you get for G of P? You want to pause it, have a quick go yourselves. Right, don't get thrown by the notation. So the examiner will expect you to understand this notation. It says we've got a function G, and what it does to the variable x is this. It squares it, it takes it 1 away from it. It takes whatever your variable is, it squares it, and it takes 1 away from it, where x belongs to the real numbers. That's what this part is. Now you can forget that part, you don't need to worry about that. And so really what you could write straight away underneath it is g of x equals x squared minus 1. Now what's this saying to you then? Well, we want g of p, but that's just the variable p instead of the variable x, so really it's just going to be p squared minus 1. But now you've got it in this form, the next question should be a little bit easier. There you go. What does it do to the variable c squared? Well, so pause, have a quick go. Well, what it does to c squared is exactly the same as what it would have done to x. It squares it first, it takes away 1. It takes whatever you've got, it squares it, takes away 1. So c squared is c to the 4, take away 1. Okay, try that. What does it do to 3a? So pause, and let's see what you got. So it took that 3a, it squares it, so that's going to be 9a squared. Take away 1. Notice it's 3a all squared, so it's 9a squared, take away 1. Always takes away 1 at the end. Last one. What does it do to that function? That's clearly a composite function because you've got a plus 1 as one function, substitute into this function. It's a combination of two functions. Okay. Let's see what you got then. So I've got my a plus 1. What does this function do? It does to anything inside the bracket. It squares it, so that's a plus 1 all squared, take away 1. Once you've got your a plus 1 squared, take away 1, if I expanded that a plus 1 squared, I'd get an a squared plus 2a plus 1, take away 1, leaves me that. So I've simplified it as well there. So well done if you managed to simplify it yourself. Right, grab your notebooks then, let's just formalise this a little bit. If you combine more than one function, you will get what we call a composite function. So if you combine more than one function, you get what we mean a composite function. So if I combine, let's say, a function f of x with another function, could be different, could be the same, it's highly unlikely to be the same, so it's a completely different function, let's say. then you get a new composite function, and we write it as fg of x. That's how you'd write it down. So fg of x is a combination of two functions, the f of x function, which could be, let's say, for argument's sake, square it and add 2, or g of x could be do sine x. So that one's like a sine function, that one's like a squared function. This is a combination of those two. So a bit of sine, a bit of x squared. And you write it like this. Now what it means is you do the f function to whatever the g function is. So that means whatever your g function is, let's say it was sine x, after you've done that sine x part to it, then you approach the f function that says square it. So you'd have sine squared. Okay. But what's important is whatever function is written next to it, so it's gx there, is the first function that's acting on it, because it get a completely different set of results. And you'll see this in a minute when you practice some of them, that you must make sure that you're reading it back to front. So it's the g function that acts on the x first. So you're looking at it in this section here. So g acts on the x first. Then once g's had its chance, then f acts on whatever's left over then. So it's g first, then f. You don't just do it as it's read. You don't do f first, then g. Okay? Always working inside out. Right. Let's have a look at why that's important then. So I've got two functions. So what does the f function do? Well, the f function takes whatever you've got inside the brackets, doesn't matter what it is, this variable, and cubes it. Okay, so I can put anything I like in that bracket and this cubes it. What does the g function do? Well, the g function takes whatever you got inside the brackets and just takes away 1 from it. That's all it does. So no matter what you put inside the brackets, it could be horrible and complicated, and all it does is just takes away 1. Takes whatever you got, take away 1. And what I need to do is work out these two functions, fg of x and gf of x. Okay, right, we'll work on this one together, first of all. So fg of x, that means you do the g function first, and then you get the f function. So let's have a think about the g function. If I had g acting on this x value just here, what it does is it just takes that x value and does -1. In fact, you could just substitute that bit straight in there, because it tells you g of x equals that. So I've substituted it in. Now I consider what the f function does, and this is where you practice those basic ones at the start of the lesson. You take whatever you got inside the brackets and you follow the rules for the f function. You take what's inside the brackets and you cube it. So what do I end up with? X minus 1 cubed. That's it, finished. That's what fg of x would look like. Okay, let's compare that to the other one. If I did it the other way around. Okay, so this time it's the f function that has a chance first. What does the f function do to x? It cubes it. So really it's gx cubed. Now it's g's turn. What does the g function do? Well, the g function takes whatever you got inside the brackets and just takes away 1 from it. So it takes whatever you got inside the bracket, take away 1. Now in this case, I have x cubed inside the bracket. So my answer at the end will be x cubed minus 1. Very different functions. Make sure you write them down right. Make sure you read them correctly. Always inside out. Okay? And generally it's not true. In some cases you can have certain functions that are true, but not very often. Right, looks a bit of a mess this. Let me explain what you're doing. You're having a go at these. So can you have a go at using the h function with x minus 3? So that's the h function just with x minus 3. So that's a bit basic one. Gets more interesting. My only bit of advice is when you get down to g squared, think about g squared. That is the same as g of x. Okay, so think of that as g of x, and think about how you work on that one. Okay, right, so have a quick go at those. See if you can find a solution to those 11 questions. Okay, so pause. I'll run through the answers now. Okay, so just to give you a bit of help, there are your solutions. So those solutions should match up with yours. If they don't, if you've got different ones, you might have done something wrong. So just double check. Okay, you might want to pause and just check your answers, and I'll pair them up. Right. So let's see what you should have got. That first one, h x minus 3 was just putting x minus 3 straight in there where x is, because the h function does 4 lots of it and takes it away from 11. So well done if you got 23 minus 4x. This one here, take the x plus 1, stick it in the n function. So we've got n plus 1 squared plus 2 lots of x plus 1, take away 3, and it simplifies down to just that. What about this one? You take the g function, 2x minus 9, and you take that 2x minus 9 and you put it in the f function. So it's 3 lots of 2x minus 9 plus 7, and well done if you manage to get 2 lots of 3x minus 10 at the end. GH of x, so you take the h function, there it is, 11 minus 4x, you take it, you stick it in there, and what do we end up with? 13 minus 8x. Okay, what next? F of x, so that's taking the f function, 3x plus 7, and substituting it in there, so it's 3x plus 7 squared plus an extra 11, gets us this bit just here. What about if I swap those around? So that's taking the m function, x squared plus 11, and substituting it in here. So it goes in where x is. 3 lots of x squared plus 11 plus 7. What does that get you then? Well, it's going to be 3x squared plus 33 plus 7, which is just 3x squared plus 40. Ng of x, so I've got my g of x function, there it is, 2x minus 9, and I'm substituting it in there and there because that's what the n function does. Doesn't matter, it's got 2 variables. Put it into those 2 places, and what do you end up with? That once you simplify and factorize. Okay, so now it gets a little bit different because the FGH example just here is you do the h function first. So that's 11 minus 4x. You take that 11 minus 4x and you run it through the g function. Now the g function doubles it and takes away 9. So it doubles that and then takes away 9. Then once you've got that answer, you then put in the f function. What does the f function do? It triples your answer and adds 7. So we do that, subbed in there, we get an answer, we sub it in there, we get the final answer. And well done if you got 46 minus 24x. Okay. Right, so I've just talked briefly about this. G squared means GGX. What does that mean then? It means take your G function, 2x minus 9, and then once you're happy with 2x minus 9, you substitute it back in to the function. What does the function do? It doubles and takes away 9. So you take your 2x minus 9, and then you double that and take away another 9. So 2x minus 9 doubled would be 4x minus 18, take away another 9. So well done if you got 4x minus 27. Okay, same here. M squared x means mmx. So you take your m function, x squared plus 11, and you substitute it back into the m function. What does the m function do? It squares your answer, it adds 11. It squares your x squared plus 11, and then it adds another 11. So you end up with that one just there. And the final one, which you know the answer is going to be that, but let's just double check we know what it is. Take the h function, 11 minus 4 lots of x, and follow it through again. So 11 minus 4 lots of 11 minus 4x. Get an answer, put it in the machine again, because it's 3 of them. 11 minus 4 lots of that answer. And then finally, you would have got down to 143 minus 64x. Okay, so that's you practicing your composite. Okay, so let's have a quick look at how range domain is affected by composite functions. So the first thing I'd like you to do is just see if you remember a bit about range domain. See if you can work out the range domain of the function f of x. Okay, so hopefully you thought about what the graph looks like. Looks something like this. So we can tell that any value of x can be put into this function. Doesn't matter what you put in, it always works. So the domain is definitely going to be all values of x. And the range of answers you can get out is going to be every single possible answer. So a linear function, as you know, has a domain of all values of x and the range of all possible values of f of x. Okay, let's try this one then. So there's a second function, g of x, which is the root of x minus 2. So have a think about what the range and domain of that function is. Okay, just replay when you're ready. Okay, so there's your graph of the square root of x minus 2. Now we can see here that this is unlike the last one where you could put different x values in. None of these x values here, like number 1, definitely doesn't hit the graph. So therefore those are not within its domain. Where's the first number in its domain? It will be the number 2. And in fact, it'll be anything greater than number 2 will work in this function. So its domain is 2 or greater than 2. What values can you get out of it though? Well, the values you can get out will be anything positive. Anything positive definitely works. You might have to go really far over here, but it'll definitely work. But nothing negative. So the only values that work for the range are anything greater than 0. So there's a range of possible results. What I'd like you to do now is see if you can work out the range and domain of the function gf of x. So just pause, have a think about it, have a go at sketching it, have a go at working it out. Okay, so if you try to work out what gf of x is first, which is a good idea, so it's the f function, which we can see there, goes into the g function because that's the next, so we end up with x plus 3 minus 2 square rooted, which is that function just there, the square root of x plus 1. So we can see that very similar to the previous one, it definitely works for all x values from minus 1 upwards. So x is greater than minus 1. What values can you get out? You can get any positive values but no negative values. So the range of gf of x is anything greater than 0. The question is, where do these two values come from in relation to the original two functions? So that's what we're going to look at. So the first thing you probably noticed is the gf of x function is exactly the same as the g function, and that would be correct. Okay, because the last function you've got here is to do with the range. That's the last function you work on. That will be the range of results. So because gx is equal to 0, that's the reason why this one has to be greater than or equal to 0. But the f function is the first function you have in here, and that's to do with the domain. Now, according to this, the domain works for all values of x. But the problem is, it quite clearly states here that the domain is not the same as the original. So where does it come from? Well, let's have a think about why this has been cut down. If you look at halfway through, so after the first function, okay, so the first function, you had a range of possible values and it said all values can come out. The problem with all values coming out is that when you try putting them into the domain of the second function, it only works for x is greater than 2. So there's no point in all these values coming out when you are restricted to only having greater than 2 when you did the second function along. So this is where the restriction comes in. This restriction of x is greater than 2 for the domain of the second function comes from the range of the first function. So if the domain of the second function is x is greater than 2, that means that this greater than 2 restricts the original range. Now if the range is restricted, so in other words we're only interested in f of x is greater than 2, greater than or equal to 2, that means that the domain is also restricted to get that possible range. So that original range is greater than 2, so therefore the domain is restricted to x is greater than or equal to minus 1. And that is where the domain of f of x comes from. Okay, so something else you might be expected to do is actually solving equations. Solving equations of composite functions. So what we're going to look at is just these two functions here, and then the composite function equaling 9. We're going to have a go at solving it. So get down your notebook, have a go yourselves, trying to work out what fg of x is, and then make sure you've got this nice and neat in your notebooks. Okay, so let's see how far you might have got then. So first thing we need to do is definitely work out fg of x. So it's the g function, 3x minus 2, substituted into the f function. What does the f function do? takes whatever you got inside the brackets and squares it. So in this case, it's got the 3x minus 2 inside the brackets and it squares it. Right, that's it done. Now we need to find when is fg of x equal to 9. Well, if I know that fg of x is equal to 9 and I know that fg of x is equal to that thing, those two must be equal to each other. So what does that tell me? Two possible solutions. You can expand if you want to and solve a quadratic, or you can just square root both sides. So it could be equal to 3, or it could be equal to minus 3. So therefore, if it's equal to 3, x is going to be 5/3, and if it's equal to minus 3, x will equal minus 1/3. Okay, so you've got just a few questions to have a go at there on those two pages, not just to do with composite or they're all to do with composite functions, but some might be solving equations, some might be to do with range and domain. So make sure you have a quick go at all of those different exercises in there. And again, although composite functions is pretty much finished there, you don't want to miss out on these relatively easy marks when it comes to your exam. So make sure you do lots of practice.